right. These last two videos, or last video, excuse me, what we're basically going to look at is that they change the way that the wording is given inside the problem, and what they're basically going to ask you, they're saying, you know, if my 0 is a k and k is equal to -1, would it be a root? Would it be a solution? Would this work? And you can use synthetic division, you can use your graphing calculator, you can use whatever you want, but the whole idea is that we're supposed to test this k value to see if it works. So all you're doing here is just an interpretation thing. So let's do this longer one. So make sure you're paying attention that all your terms are being accounted for. So we have an x cubed, we have an x squared, we have an x, and we have a constant. So everything's accounted for. So in this case here, since they've given us our k value, we don't need to convert that over from a factor to a 0. It's already, they're saying, if my 0 was k, and k was equal to -6, would it work? Would it give me the right thing? I bring down my coefficients, so -2, -14, -13, and 3. I start my process. Bring down my -2. A negative times a negative is a positive. I add those two together, I get -2. A negative times a negative, use my arrows, sorry about that. A negative times a negative is a positive. I add them together, I get -1. A negative times a negative is a positive. I get 6. I add them together, I get a remainder of 9. So in that particular case, k would not be one of my zeros, because since when I plug this in, I get a remainder. Recall that the idea here that's going on is like, it's like saying, if I took -6, excuse me, let's get rid of the negative. We don't want that on there for conversation purposes. So, I mean, these are not the numbers we're talking about. It's like saying if I took 6 and tried to divide it into 55. 6 doesn't go into 55. 6 goes into 54 9 times, but I have a remainder of 1. So 6 doesn't go into 55 evenly. So in this case here, 0 of -6, this graph is not going to cross the x-axis at -6. If we look at the graph in the graphing calculator, -6 will not be one of my x-intercepts. All right, so take a look at this guy real quick. We'll do the same thing, -1, do it very quickly, 1, -3, and 3. We bring it down, that's 1. We multiply, that's -1. We add, that's -4. We multiply, that's +4. We add, that is 7. So once again, this -1 would not be a solution for this particular polynomial because there's a remainder, because of the remainder. All right, last piece here. What about if we did it with imaginary numbers? What if we used k, they gave us k and it was imaginary? How would we do that? Well, same deal. We take 7i and we set this thing up. Now pay attention. 2x squared, but we're missing our x. So we got to put a 0 to account for our x. So 2, 0, 46. All right? Go through what you know. Bring down the first term. That's 2. Multiply. 7i times 2 is 14i. Add. That's 14i. Multiply. 7 times 14, gotta look, sorry. 7 times 14 is 98. However, in that case, I take the I squared, right? Because that would be 98i squared. But recall that I squared is actually equal to -1. So in this case here, this is actually going to turn out to be -98. So then I have 46 and 98. -98 gives me -46. But more importantly, it doesn't divide unevenly because it has a remainder of -46. So k is not a 0. So 7i is not a 0 or a solution or a root. Okay, let's try the next one and we'll wrap this up. So 4i, and we got 3. We got to put our placeholder in there, and 48. All right, so we bring down the 3. 4 times 3 is 12i. We add that together, we get 12i. We multiply 4 times 12. We know 4 times 12 is 48. We know I times I is I squared. So technically that's negative 48 because the I squared is a negative 1. So we have positive 48 and negative 48 that gives us a remainder of 0. So in that case there, x is equal to 4i. That is one of my solutions. All right, so play around with homework 3.4 based upon these videos, and we'll keep building on this. Send me questions when you have them.